Welcome to the video lecture Digital Communication. Myself Samda Pratima, Assistant Professor, ECE Department, RMK CET. In this video lecture, we are going to see the topic I pattern from the Unit 3 Baseband Transmission and Reception. Usually, the quality of digital transmission systems evaluated by using bit error rate. If the bit error rate is good, then the quality will be high. If the bit error rate is not up to the mark, then the quality is said to be degraded. Now, this degradation of quality of digital transmission systems will be analyzed with the help of I pattern. So, before going to see what is I pattern and how it is plotted, and with the help of I pattern how to analyze the degradation of digital transmission systems, why it is called as, we need to know why it is called as I pattern. Since this plot used for analysis will resembles like a human eye, so this is called as I pattern or I diagram. Now, the I pattern is experimental tool which gives information concerning the degradation of quality, and it evaluates the effect of ISI and channel noise. It will tells how much got the system how much affected by ISI and as well as channel noise. And how it is plotted means it is plotted with the help of CRO, cathode ray oscilloscope. And you know how to plot the signal with the help of oscilloscope. It is having two deflection plates. Whatever the signal or waveform we need to plot or display on the CRO, it is given to vertical deflection plates, and the time synchronization wave will be given to horizontal deflection plates usually in the laboratory. Here, to plot the I pattern for vertical deflection plates, we will give the received distorted wave, and for horizontal deflection plates a synchronized sawtooth wave will be given, which is having the same bit duration. Now, actually the I pattern is it looks like a composite signal which reflects the channel bandwidth, attenuation, jitter and rise or fall time variations. So, it consists of all these parameters, and the interior region, the inner side, that region is called as inner side region of the I pattern is called as I opening, and this I opening will tells you how much the system is degraded by ISI, and I pattern will provide the performance of the system. Now, here these ones and zeros are showing the distorted binary waveform. So, 1 got distorted like this, and 0 got distorted like this, and this one got distorted and it is dispersed to second pulse, and this 0 is distorted like this. So, this is received distorted binary wave. Here we have used the polar representation. Polar means the binary 1 is represented by positive voltage and 0 is represented by negative voltage. So, 1 is represented by positive voltage and 0 is represented by a negative voltage. So, it is called the polar representation. Now, let us consider this is the distorted received incoming signal. Now, if we give this to the vertical deflection plates, that is Y, this point, if we connect that incoming signal to the CRO point Y, that is vertical deflection plates, and for horizontal deflection plates a sawtooth waveform at the rate 1 by TB. Here TB is bit duration. So, this bit duration TB of the incoming signal. So, it got synchronized with the received signal. Sawtooth wave is synchronized with the received digital signal. Then this CRO display will be like this. So, it will display a waveform like this. It resembles like human eye. That's why this pattern is called as I diagram or I pattern. Now, this interior area is called as I opening, and here it is having width of TB, the pulse duration, this one TB width. So, how it resembles means it resembles like human eye. That's why it is called eye pattern or eye diagram. And it is a superimposition or superposition of successive symbols. So each and every symbol, these symbols will be here superimposed. It is looks like superimposition of successive symbols. Now, so this is for analytical purpose the theoretical eye pattern. So here this horizontal space from here to here, it will gives the best time interval to sample the received incoming waveform. So if we sample for example here at this point, if we sample the incoming signal, then this is best sampling time. And this vertical from here to here, this vertical distance will gives you the margin over the noise. So if this reduced this distance, then margin over noise will also be reduced. That means we cannot tell either noise, because of noise we received the bit, or because of the signal we have received the bit. So if the length is decreased, then we may get confused, we may lose the information. So if this eye opening is high, then the system will be better at reception or detection. Now this distance is called distortion due to zero crossings. So here it is said to be zero crossing point, and because of this some distance, there exists some distance, because of this distance there will be some distortion, and that distortion is called as a distortion of zero crossings. Now this slope of the eye diagram, this slope of this pattern will gives you the sensitivity to timing error, and this from here to here, this vertical short distance will provide the distortion at the sampling time. At best sampling time also we are having some distortion, so this is that distortion. So this is the theoretical eye pattern for analysis purpose, to analyze the performance of a digital communication system. As I explained in the diagram, so the same it is given in this slide. The width of the eye opening defines the time interval over which the received wave can be sampled. The width will gives you the best time without an ISI. And next, the sensitivity of the system to the timing error is determined by the slope of the eye pattern. Next, height of eye pattern at the specified sampling time defines the margin over the noise. And when the effect of ISI is severe, then the eye is completely closed, and at that time it is impossible to avoid the error due to combined presence of ISI and noise. So if ISI is somewhat mild, then this eye opening, eye pattern will be used to analyze the distortion. If eye get completely closed, then we cannot overcome this ISI, then we may lose the signal. So this is the practical eye diagram. It is plotted for M-array signaling. So there are 1, 2, 3, 4, 5, 6, 7, 8 eye diagrams. So it is showing eye get completely closed. So we cannot, it is possible to eliminate the intersymbol interference in this case. This is the practical eye pattern diagram, which is plotted with the help of CRO. So now I hope you have understood what is eye pattern, why it is called as eye pattern or eye diagram, for what it will be used, that is to analyze the degradation of the digital communication system or performance of digital communication system.